Well, we've got a million decisions to make, don't we? Here's one of this, like, I'm just starting to figure out what I want to do for an instrument cluster. But you can use drag bars, you can use low Euro bars, you can use Clubman bars or clip-ons. There's a myriad of different styles and configurations that you can use. And I am not really a big Clubman fan, but I thought because of the size of the instrument, which is, they're pretty big, and I wanted to use a standard instrument, I'm not going to use both. I'm going to throw away the speedometer. I'm going with tack only. I'm going to center mount it, put an ignition switch up there, and then that's it. All the idiot lights are actually going away. I'm going to make a wiring harness that's conducive to what electrical functions I actually want. But there's a couple key things that I wanted to show you that are very important. First off, if you're going to use like a Clubman, you're going to have to change out the reservoir. I'm still using a single front disc brake, but the reservoir, to get that angle, you see that nice angle? That's off an RD400. So I'm going to use an RD400 front reservoir so I can get that reservoir almost level. If you can't use the stock Honda reservoir, you wouldn't have enough fluid in the bottom of it to actually make it functional, or at least safely functional. So there's one thing right off the get. I've already started mocking this thing up, and I put all the engine hardware back in where it goes to make sure that I have the correct hardware. And I'm going to do rear sets. And I've already mocked up the rear sets. I didn't mock them up. They're actually welded in place, but they're just not finish welded. And then here's my rear set configuration here. You see how I do that? I take a piece of solid mild steel rod, and I drill out the center. Then I can cut it to length, and then use a long bolt to actually hold this whole mess together. Use a ball joint that you would see like in carburetor linkages, and then recut in where the brake arm used to be, an acceptor for that ball joint, so everything works fairly well. That's my rear set. I removed everything from the swing arm that I don't want, because I'm not running chain guards, so I removed all that junk. And it's all been cleaned up and ferried away. Here's another look before finish welding. It's just welded in place to hold it, of my extensions for my left side rear set. I've got something kind of a little bit different on this rear set. You see where I'm actually going to take my power from was from the center of the shifter. That rod's been welded back in place so I don't lose any strength from the shifter, but the shifter is going to come to the engine there in a straight line. I'm going to be pushing down on it. This is going to reverse my shifting pattern, but with the rear sets that I've seen offered and the ones that I've seen on different blog sites and stuff, I think this is going to work better than theirs, and I'll let you know how it works. I've removed from the battery box everything that I don't want, and there it is right there. Everything has been removed that is not necessary for the type of operation I actually want to do. And obviously this all stuff is going to go in for sandblasting and then powder coating, right? Here's something that is specific to the 750 Honda that really bugs a lot of people. The 750 top end can't be rebuilt because you can't get the valve cover off without having the engine out of the frame. So this section of frame, which is just under the main backbone, I'm actually putting brackets in right through here, and then again back through here, cutting this away and then putting a strap over it where it can be bolted. So I'm going to take this little triangle section of frame and be able to remove it, take it off the bike, so I can do a top-end rebuild in the frame, and then it just makes it a whole lot easier to service and maintain this motorcycle. They have a bunch of kits on the market that you can actually do that, and they're several $100s. I don't know why. I don't know why people buy that stuff. This is just as easy to do. So I've just started the cut on the frame mod. I'll tell you what, I'll get right back to you after I'm done with the frame mod. You can see how the thing works. But I've moved this, my CB750 Cafe racer, further down the line. And I hope you watch and enjoy the series. So here's that frame modification I promised you. You can see that I built everything in place along the frame member with 1-inch steel, 1-inch by 1/4-inch steel strap. And here's the frame section. that gets removed so I can take the valve cover off and there too take the head and barrels off and do a top end in the frame. It's pretty simple. Slides in like that. Then we'll be installing a series of bolts to hold the frame member together. And that makes it a 750 that's real easy to do top end service on. Copy it if you want to. It works well for me. Is it as strong as the factory original? I don't think so. I didn't do the engineering calculations, but I know it's plenty strong enough for my needs. And it looks a whole lot stronger than the kits that I've actually seen available. And it probably cost me around $8 worth of strap steel and about $4 or $5 worth of really nice grade 8 bolts. So check that out. If it's something that you're inclined to do, you just got to do it before you go to powder coat or paint. There you go. Hey, this is Robert. I'm back with you on the CB750 Cafe fabrication. And I'm going to talk about side covers just for a little bit. It's kind of a distraction from the fun part of the build because these side covers are always, mostly always, very, very brittle. And just taking them off the bike, they explode. This one's been partially repaired, not completely. But you can see that there was crack through here, and you might be able to see there's a crack through here. And the other thing I want to do with these side covers is you can see that Honda on the 77s and 78s framed in the air box with a portion of this side cover. Can you see that? And I didn't like that because I'm going to be running uni oval pods for my air cleaner system, and this will make those uni pods look funky. So I'm going to cut that away. I've repaired one side cover already and cut away. This is the opposite side. It looks like that. And the bottom of this was actually missing, and I put it back together. And it looks like this on the inside. Barely see the repair because the material is translucent when it's actually dries up. I don't use fiberglass resin. I use marine epoxy. I used West Systems 105 epoxy and the 205 hardener. You get the pumps, you pump once down on the handle, it's a correct portion for one pump down on this handle, and it gives you, just a couple ounces of material to work with at a time. This material is really expensive, but I don't use that much of it. I might use 4 or 5 applications, 1 ounce each application to do one side cover, and considering how much side covers are, spending $5 or $10 for epoxy is not that big of a deal. My reinforcing material is 6 ounce fiberglass fabric. And this 6 ounce material, you can get this stuff anywhere. They sell it at auto parts stores for fiberglass repair. I cut it into couple inch strips, 2-inch strips. I cut the strips to fit the edges of the side cover like so. And then the next strip that I lay over, and I do this all wet. Like I'll cut it all in and then just start dabbing on my epoxies. Then I'll go at least 2 more coats. One is going to be on the bias at a 45, and then the final coat will overlap those and bring down into the main part of the body like this. But when this is all wetted down, you just keep on tapping it with an acid or with a throwaway brush, like one of these things, wetting that material down and shoving it into the corners with the bristle of the butt of the brush until everything adheres to the side cover, inside of the side cover. I prep the side cover by washing it with soap and water, and then I wipe it down with lacquer thinner, and then I scuff it up with 80 grit sandpaper. Then the other thing that I actually do is I reinforce the push tabs, which have to be done. You can see that the structure for the push tab is actually kind of wimpy, and it's hollow. So what I do is I actually drill a hole into the push tab. You see that hole I drilled? And the hole is bigger than that of a drywall screw. I cut the head off the drywall screw. You see that? I'm going to shove that drywall screw into the hole I drilled into the metal tab so it's flush. Then I'm going to tape over the edge to keep that the epoxy material in. I want it loose too, so that way the epoxy material flows through. Like that. Then I'll tape over the edge to keep the epoxy material in. And then I'll flood that little channel with epoxy. Then that way I get a really, really solid steel reinforced push tab, and I don't have to worry about that breaking anymore. Alright, I'm going to get to that, and I'll catch you on the next video.